Sure. Yeah. Very jealous of you guys in Paris. Yeah. So, hi guys. Have you ever wondered how come those hackers from last year pull off so many $1 million DeFi hacks? Are there any ways to discover them? If you're interested in those questions, you're in the right place, because in the next 15 minutes, I will show you how to explore and secure DeFi projects with something, called the formal methods. So first, a little bit about myself. My name is Xinyuan, and I'm currently doing research at Certic, and we at Certic do things like auditing and crypto infra, things like compilers and verification, etc. So formal methods have always been kind of the buzzword that, one of the buzzwords that our Ethereum talk about. If you do a Google search, you can find actually thousands of papers and hundreds of blog posts about it, with even dedicated channels and workshops. But what exactly are those contents about? Let's take a look. You see that everybody thinks that formal methods can solve everything. And of course, besides community enthusiasm, not to mention people like us in the auditing business, who are extremely bullish on formal methods using blockchain security. So, but what does it look like in the decentralized finance world? Boom and boom. The truth is, we who are so bullish on the formal methods side did not deliver our promises to the DeFi community. We have failed to find those vulnerabilities, and we were wrecked. And formal methods are not used in DeFi. So the formal methods community has produced many technologies up to now. What we have here are things like static analysis and semantic formalization. But now the real question is, how can we use them in DeFi? So before we go into and answer that question, I want to first use an analogy to give sort of a teaser to you guys and convey a simple version of the idea of our answer. Because in the crypto community, we have always been comparing building DeFi protocols to assembling Lego pieces, and therefore goes word money Lego. So what we have in mind here is to maintain this, the piece of this and integrity of this fancy Lego castle to prevent any potential problems when we are building it. And there are actually two kinds of problems. The first one would be to find those broken Lego pieces in this castle. This corresponds to finding vulnerabilities in one of the protocol's financial models. And the other kind is this very prevalent one, the composability issue. What if there are some possible harmful and non-legal ways to compose those money Legos? So how can we solve with those two problems with what we have? We have to make the extraction and reasoning of financial models in DeFi easier. What are financial models, right? Let's take a look at a quote from a veteran auditor. If you go into a DeFi audit without a full understanding about how options or derivatives work, you're probably going about it all wrong. So, and here the understanding about options and derivatives is the financial model part that is extra to the traditional software security that we should now pay special attention to. So what about a concrete example? Let's look at the balance hack with the Stellar tokens happened last year, which perfectly illustrated how weak our Lego castle can be when we have some unsound financial model. So in this case, the hacker first borrows Flash loan for his initial capital, and then he does all these seemingly meaningless transactions of repeatedly trading WATH and STA tokens back and forth. But what he's really doing is taking advantage of Stellar tokens deflationary mechanism that you can see here. Every time the attacker does a swap involving a STA token on balancer, the balancer pool receives 1% less STA than what was expected. And this inconsistency between balancer's book and its actual holdings ultimately led to the hack. So at this point, you're probably wondering how we can find financial model hacks like the one that we just presented. Right? A natural solution is to model all those all the components the hacker had used step by step, from the flash loan on DYDX to tokens, profit taking step, and finally the money laundering step. But how can we possibly verify something that involves so many Lego pieces? So here's our proposal. We take a divide and conquer approach. First, we verify each individual module. This corresponds to the individual Lego block broken problem. And then secondly, we on top of that, we search that if there are any vulnerabilities caused by the composition of those modules. This corresponds to the illegal composition problem. In Lego language, this means that we only need to consider details in the blue block, and other blocks that the blue block depends on are reduced to the specification. That is, we only have the detailed implementation of the DeFi protocol we want to verify, and for others, they are specifications. And what is search? For the composability flaws, we say that if starting from a sensible state, then if there still exists a trace of cost to those money Legos, so that risk-free arbitrage can be performed, then there essentially exists a hack. So this seems like a very hard to prove property, right? So then some optimizations we can do is to say that we search a finite space and prove non-sensible states. That means that, for example, we only consider 5 factorial permutation setups to compose those Legos. So as a first step to demonstrate our approach, at the divide stage in the divide and conquer strategy, we present how to use deductive verification with SMT solvers to prove some basic theorems about Uniswap v2. So essentially, we proved 3 lemmas that we call swap correctness, reserve synchronization, and the increasing product, which basically captures the minimal features of a constant function market maker. So, and our implementation is called Cyric, which is based on the Y3 verification language. So, Cyric showed us that current SMT methods proved some basic theorems, but many other DeFi theorems use advanced math. So to take the same Uniswap v2 protocol as an example, it can also be proven to have some properties like immunity to oracle manipulation attacks. And there are some previous works on this one, but they're really done on pen paper, which does not show hard evidence on the implementation correctness. And the formalization of current pen paper proof requires the use of some real analysis results, which are beyond what SMTs can solve. So for use to be able to define arbitrary mathematical constructs, we bring proof assistance like Coq onto the table. Specifically for our Uniswap proof case, Coq enables us to use advanced math libraries like Coq interval, and in our proof specifically, we use the general version of Taylor-Lagrange theorem formalized in the libraries to prove lemmas required for the oracle manipulation immunity property. Yay! So here we have the, so what we have here is the world's first formally verified DeFi protocol. And we were able to mechanically verify the pen paper proof on the oracle manipulation property. Say that the cost of manipulating token prices in the AMM is high, and compare with the pen paper proof, this formalized proof is more rigorous about integer approximation in the actual Uniswap implementation. For example, we consider all kinds of things like running errors, and for the complexity composed about 1,000 lines of Coq and 400 lines of smart contract model. Yay! So we can do it. So to conclude, established methods and existing tools used from an application can handle some DeFi theorems. This means that broken Lego pieces can be effectively eliminated, and we don't have to worry about them because we know we can do it. End of talk. Great story. Just kidding. But this is not good enough to move the needle, as it does not consider the composability problem, the illegal composing DeFi Legos, which is a major part of DeFi security, really. So even though it's our wish that DeFi security can be solved by just eliminating broken blocks, but we're now at the we should now consider the second stage in our divide and conquer plan, where we search for composability flaws. So our attack plan in one sentence is basically to use model checking to search risk-free arbitrage. We model the way we do it is to model depending DeFi protocols using a domain-specific language as the specification of the project's Solidity implementation. If you remember the graph from early on, this is a gray block that the blue block depends on. Yeah, so specifically for our language, we use DeepSEA, which is to extract and encode the program into format suitable for model checking. And to search it, we search a refined version of the previous property. So we can further optimize the composability flaw checking with the insight that most DeFi protocols are forks with similar functionalities. And I'm sure you're all wondering, is it really possible to search such a complicated property on the already complicated DeFi protocols? Well, we actually don't need to search everything. So for example, from the balancer and STA hack, early on, there were 27 swap function calls for WH pair alone and 50 plus for the entire transaction. We only need to consider the core of the hack, which are the blue modules, and there only need to be a few SDA token transfers to trigger the attack, which is more than the transaction fees of the balancer. So we were able to find the attack in a limited number of calls. Yeah, so one further optimization we can do is to have the insight that many of those protocols all have the same functionality, like adding liquidity master chef style staking rewards or smart mining, blah blah blah. And another thing, this is because BSC has been accumulating popularity for the past few months, and you can see that most hacks on BSC are forks with some tweaks. For example, the uranium finance one, which is a tweak of the Uniswap V2 token pair contract. Yeah, and then as a result of those insights, we are in the process of building a DSL model DeFi library, which contains variants of the DeFi projects with a TVL larger than $50 million. And I want to highlight that this is a non-repetitive work, which means that this library can be used for divide and conquer approach in the future. So to conclude, we have seen evidence that a spectrum of methods ranging from design verification to proof assistance and to model checking works for DeFi. At this time, we can confidently say that we have the ability to build a Lego castle that is strong enough to withstand the blow of the big bad wolf. And that Lego building tip was the takeaway. And actually, in this talk, I want to call for a manifesto based on what we have just done. That as a community, we should really push for the full methods used in DeFi. But it's more than that. There's some deep ideological thing that we should all watch for here. That full methods are neutral. They embody the very spirit of crypto. By replacing trust in human auditors with a mechanized, decentralized version of provable security. So it really is about another step into the trust minimization process. So it truly democratizes DeFi and gives the power back to the community. So our strength is stronger. So thank you all for listening, and I hope my talk did not just inspire a bunch of hackers. And now it's Q&A time. Yeah.